Good afternoon, students. So this one is the other pretest analysis, and this one is getting down to the final unit of Unit 6. You probably noticed that there's Unit 7, but Unit 7, that's just a review for the final. So Unit 6 is the last new contents that we need to cover. So it's all about circles. So again, this one is for geometry, summer geometry, semester 1, so circles. So which of the following is best described as all points on the plane that are the same distance from the single point called a center? So anytime they see something like that, all the radii from the circles, they're always the same distance, so this one is a circle. So which of the following best describe a circles? So circle that all points on the plane that are the same distance from a single point called a center. Okay, so question number 2. So which of the following is represented by segment DV? So it's a radius. So anytime they see the distance from the center to one point on a circle, so it's always called a radius. So radius is half of the diameter. So it's all radius. And which point represents the center of a circle shown below? The center is always right in the middle of the circle. So it's point K. Okay, so this one's point O. And here's point A. And what's the circumference of a circle shown below? The way to find the circumference of a circle, it's 2 pi r, or pi times the diameter. So 2 pi r, try to use that formula. So 2 times pi, 3.14, times 10.5, and then you'll get 66. So 2 times 3.14, which is the value of pi with approximation, and then times the radius, 10.5, so you get 66. And here's another one, so 2 pi r, so 2 times 3.14 times 6.1, then you get 38.3. Okay, so that one's quite similar. So which one of the following represents the diameter of the circle below? So segment EF or segment FE. So this one, the selection we have is segment EF. So this one would be segment TH, the diameter. It's always from one endpoint on the circle to another endpoint on the circle. But by the time that you connect them, it's going through the center of the circle. So that's always the diameter. So here's another one, XY, diameter. And which of the following is best describe the line segment that has both endpoints on the circle? So usually to be a diameter, but also the diameter can be called the chord on the circle. So a line segment that has both endpoints on a circle. So the difference of a chord and the diameter, because chords sometimes just connect 2 points on a circle, it's not necessarily to go through the center. So the chord, so that's the only difference compared to the diameter. So the diameter, it's always going through the center of the circle, but a chord, it's not required to go through the center of the circle. And which of the following best describes segment SQ? So that's a chord. Again, see that doesn't go through the center. And which of the following best describe the relationship between the chord segment AC and segment FD? So anytime they see the equidistance like this, showing that perpendicular, 7.12, 7.12, so that means those two chords must be congruent. So they're congruent chords. And this one too, congruent chords. And then number 8. So what's the length of segment AC? So segment AC, so this one, the radius always bisects the chord going through if that's showing perpendicular. So half of it, it's 8. So that means the entire length of chord AC, it's 16. 8 times 2, or 8 plus 8. So 12 plus 12, 24. And then this one, the entire length, it's 18, so half of it, which is 9. And now question number 9. So minor art, that means the smaller art, it's always less than 90 degrees. If that's a major art, sometimes greater than 90. So art AB, so this one, that's the name of the minor art from point A to point B. So that's the art right here, 100 degrees. Not necessarily to be less than 90, but sometimes could be, it's just like a smaller art compared to the major part. So you can go around this way, counterclockwise, or you can go by clockwise. So try to go by if you try to go by counterclockwise, this one would be the major arc. But this one going by clockwise, so it's the minor arc. Okay, so this one's chord, not a chord, but it's R18, minor arc. So minor arc here, so then that would be RA. Again, the little curve right here, that means the arc. Just a symbol for arc. It's a geometric symbol. And then this one showing that the congruent arc. So you can say that RAB is congruent to RCD, or CD is congruent to RAB. And then XWX is congruent to YZ. So GJ or GH is congruent to KJ or JK. And what's the form? So what's formed by two line segments that connected the center of a circle to the endpoints of an arc. So then that'll be a central angle. So anytime that you see that the angle is being formed by two radii, so this one is always considered a central angle. So a central angle is best described as it's an angle that has the vertex at the center of the circle. So here's a diagram showing that it's a central angle, 142 degree. So it's always constructed by the center and then connected to the endpoints, two endpoints on a circle with two radii. So what's the measure of angle DOC? So DOC is the same as angle AOB. Since we do know those two they're congruent, so that means the central angle got to be congruent as well. So 65 degrees. So since we do know that measure RWX is the same as RYZ, so 105, the central angle, which is the same as the measure of the arc. So this one is also 105. So 72, the other one is also 72, it's quite straightforward. So what's the measure of the major arc? So the way to find the major arc, since we do know the minor arc is 150, so the way to find the major arc is just 360 minus the measure of the minor arc. So 360 minus 150, then that'll be 210. So 360 minus 135, 225. 360 minus 150, then that'll be 210. Okay, so are the arc below congruent? So the things that they're both facing to the different arc here, so the central angles, they're different, so the arc, they're different. No, because that the arc do not have the same measure. Again, arc had the same measure, that means the congruent arc. If they don't have the same measurements, so that means they're not congruent. So this one is off by 2 units. So no, they're not congruent. And now here's another one. So given that circle O below, if RAB, so here we go, RAB and RBC right here are congruent, what's the measure of chord BC? So chord BC, so if chord AB is 14.5, that means chord BC is also 14.5. Because this one we can show that those are the congruent triangles. So that means the segments here got to be corresponding. So that means they got to be equal. So it's also 14.5. So ZY is 11.2. So that means XY it's also 11.2 unit. Okay, so 8.6, 8.6. And now what about for angle ABC? So anytime that you see the angles formed by two chords, so this one is called the inscribe angle. So the inscribe angle is always half of the measure of the corresponding arc. So in order to find out the measure of RAC, so it's always 2 times 44. 2 times the measure of that inscribe angle. So this one is called the inscribe angle. Again, it's formed by two chords. Inscribe angle, so just name the figure. Okay, so now inscribe angle is given, so you want to find out the measure of the arc. So again, half of the arc, it's the measure of the inscribe angle. So in other words, so twice as much as the inscribe angle, then that would be the measure of the arc. So 2 times 62, then that would be considered 124, and that would be RAC. And what's the measure of arc? JL, it's actually the minor arc, so JL, which is this one here. Okay, so 2 times 82, which is 164 degrees. And what's the measure of RXZ? So 2 times 58, so it's 116. And now, in order to find out the measure of the, this one is called the inner angle. So angle DBE, so DBE right here. Okay, so let me just copy down the diagram, so and then we'll just do the analysis on the pre-median slide. So again, if you see anything that's bounded by two chords, so the angles, okay, so I think I did something wrong here. There we go. So anytime they see the angle formed by two chords and they're both intersected, so let's say that the angles, so either you need to find this one or this one because their vertical angle is the same measurement. So the way to find this angle, so let's say that in general this one is called the inner angle in a circle. Okay, so the way to do it, so it's 1/2 times the measure of the major arc plus the measure of the minor arc. So once you combine those two, major arc, minor arc, what I mean by that, minor would be this one, and then the major, then that would be this one here. So 1/2 times the quantity of 45 plus 75. So 45 plus 75, which is 120. So half of 120, then that would be 60 degrees. So anytime that you see the problem like that, finding the measure of the inner angle, so we use the same formula. So it's 1/2 times the quantity of the major arc plus the minor arc. Okay, so now let's go back to this one. So 60 degrees. And the other one, so similar situation. So 1/2 times the quantity of 47 and 77. So once you evaluate it, 62 degrees. And this one too. Again, it's always bounded with two chords. Now be careful with this. The point where they intersect, that's not the center of the circle. That's just the point where they intersect with those two chords. The center of the circle is somewhere around here. And now, what about for number 19? So how do you find out the measure of that angle? Which one of the following? Okay, well, let's just do some analysis first. Which of the following is a secant on a circle below? Secant, that means it's a line segment or a line going through 2 points on a circle. So this one, you can say that it's line AB. You don't want to say that's a segment, because segment, that's from point A to point B. And then you just stop. So it's a line going through the circle at 2 points. So line AB, you see that with 2 arrows. And then which one of the following is a secant on circle below? So this one would be line RT. Okay, so this one would be KI. It's a line with the arrow. Again, it's not that clear showing the arrow. So make sure that you need to read through the symbol. If that's just a bar, that means the line segment. If that's a curve, that means the arc. But you see the line with 2 arrows at the end. So that's the line. So it goes all the way non-stop. So 20. So what's the measure of RAC? So this one, you just use the same formula to figure out what the R is. So since we do know that they're both consider vertical angle, 39, 39, and this one's 37. The thing is that you don't want to assume that they're the same measurements. So the way to do it is by using the same formula we were talking about. So the inner angle is always the measure of half of 1/2 times the quantity of the major arc plus the minor arc. So now let's just do this one on the pre-median slide. Copy image. And copy and paste right here real quick. Okay, so the one that's missing, it's RAC. So that one would be considered either the minor arc or the major arc. Okay, so the way to do it, so we do know that the inner angle is 39. So 1/2 times the measure of the minor arc, 37, plus the major arc. So let's say the major arc is X. So solve for X. So multiply by 2 first. So you'll get 78. Okay, so what I did here, just multiply by 2 on both sides. because you want to get rid of that 1/2. And then the next step, so we just end up with 37 and x. And then you subtract 37 both sides. So once you subtract, so x would be considered 41. So 41 degree, then that's the measure of the major arc, AC. Okay, so now let's see what else that we have for the rest of this. So the next one is quite similar. In order to figure out the major arc or the minor arc, you use this exact same formula for this, the inner angle formula. And now let's talk about the tangent angle. So which one of the following is a point of tangencies on the circle below? So anytime that I see the line that going through the circle at one point, so that means at that point it's called a tangent point or the point of tangency. So point B, it's the point of tangency. It doesn't go through the circle, it just touches the circle at one point. So if you see the line going through the circle, barely touching it at one point, so that means it's called the point of tangency. So here's another one. So point Z, that's the point of tangency. So you might be wondering the chord here, what's happening with this chord? This chord has nothing to do with this tangent line, okay? So that's just showing the point where they intersect, it's point Z. So here's another one. So the line which is tangent to the circle is line FG or GF, and the point of tangency is point F. So what's the measure of angle ACE? So here's another problem. It's quite similar to the inner angle, but this one is called the external angle. Okay, so again, I'm going to copy and paste. So I can do on the previous slide here. So how do we find the measure of the external angle? With two secant line. So this time we need to solve for angle ACE. So this external angle here. The reason why that I call it external because that's outside the circle. So the way to do it, it's quite similar to the inner angle formula. So the external angle. So the way to do it, it's 1/2 times the quantity of the major arc minus the minor arc. So just abbreviate that major minor. So 1/2 times the major arc, obviously compare and contrast. The one that's bigger, that's the major arc, so it's 104. Minor arc, then that'd be 46. So once you subtract, so this one you'll end up with 58. And then divided by 2 or multiply by 1/2. Then this one you'll get 29 degrees. So that's the measure of the external angle, angle ACE. So check it out. Back to what we found here. So 29 degree. So here's another one. So it's always 1/2 times the measure of the sums of the major arc plus the minus the minor arc. Because that's the external angle, not plus, minus. In order to find the inner angle, you need to combine those two arcs, major and minor. But once you need to find external, always subtract those two arcs before you divide by 2 or multiply by 1/2. Okay, so basically that's pretty much about the external angle. And now what about, let's say that the minor arc it's not given, and that's what we need to find out. So in order to find the other one, so this time we need to find the minor arc. So it's quite similar to what we're doing, but this time we need to set the unknown variable for BD, RBD. So external angle formula, once again, so it's 1/2 times the quantity of the major arc minus the minor arc. So external angle is given already, so it's 18. So it's 18 equals 1/2 times the quantity of the major arc, 83, minus the minor arc, x. So the way to solve for x, first thing that you want to do, multiply by 2 on both sides, so you'll get 36. So that goes 83 minus x. And then basically it's x, so the way to solve it, so 83 minus 36, swap the number in the terms. And then we do have 47, so 47 degrees. that's the measure of the minor arc. Okay, so going back to the page here, 47 degrees. So here's another one. So using the same formula to find the missing arc. And also we can use the same formula to find the missing arc for the major one. So depending on which one is missing here and which one is asking for. And what's the measure of RBA? So this one is quite similar to the inscribe angle. So if that's a tangent angle, the measure of the tangent angle is always half of the intercepted arc. So in order to find out the measure of the intercepted arc, we're going backward. So 72 times 2, then we'll get 144. So the measure of the corresponding or the intercepted arc, AB, then that would be considered 144, or BA. So here's another one. So 2 times 84, so 168. 2 times 78, 156. Okay, let's see what this one is. So what is the measure of angle ABC? So again, find the measure of the external angle. So the one that we saw, that's the one being bounded with 2 secant. This one, it's bounded by 2 tangent line. So it's the same formula that we're using. It's the external angle. So 1/2 times the quantity of the major arc minus the minor arc. So we get 48. So this one is being bounded with 2 tangent line. So again, find the measure of the external angle, XYZ. So 1/2 times the quantity of 233 minus 127. So we get 53. Okay, so it's pretty much the same type of problem. Now, what about this one right here, 26? Again, 2 tangent segment, 2 tangent line. And we need to find the measure of the major arc or the minor arc. Again, using that formula, 1/2 times the quantity of the major arc minus the minor arc. Okay, so let's do one more problem like this. Then the rest of that, they're pretty similar. Okay, so now let me just copy and paste that here. Okay, so it looks like this one is missing with the minor arc. So RAC or CA, depends on which way that you read through it. So the way to do it, so we said that 20, so that equals 1/2 times the quantity of the major arc, which is 200, minus X. Again, isolate the variable, so we need to get rid of the 1/2. So in order to get rid of the number here, so we multiply by 2 both sides, so we got 40. So 1/2 and 2 got cross cancel. So X equals 200 minus 40, then that will be considered 160. So the measure of RAC is 160 degrees. Okay, so going back to what we found here, 160. So the next two problems, they're quite similar. And number 27, so which of the following best describes the distance around a circle? That's a circumference. The way to find the circumference of a circle is 2 pi r, or pi times the diameter. Okay, so for number 28, 2 pi r. So which expressions, when multiplied by r, produce the formula for the circumference of a circle? Multiply by 2 pi. Okay, so 29. So what's the measure of theta? So theta, that would be the measure of this central angle here. So the way to do it, so this one, it's all about the arc length. Okay, so let me just highlight this problem here. Once again, copy and paste. So what I'm talking about, so 12 centimeters, so then that's just the arc length from one point of the circle to another point. So let's say this one's point A, this one's point B. So this measure of the entire arc here. So this one is 12 centimeter. So the way to find the arc length, it's always the radius times theta. So there's a proof for that one, but you don't need to know the proof. So I just want to show you what the formula is. So this one is called the arc length. So where S is the arc length. So radius, so then that's 3. Theta, we don't know what that is. So arc length, it's given already, so it's 12. So 12 divided by 3. So the radian, then that'll be 4. And the unit for the radian, it's always considered RAD, rad. So the answer is 4 radians. And here's another one. So 12 divided by 4, so it's 3 radians. 20 divided by 5, so 4 radians. So question number 30. So what's the circumference of a circle? Well, that one's pretty straightforward. 2 pi r, so 2 times 12, 24. 24 times pi, 3.14. Then you'll get 75.4 centimeter. It's all about 2 pi r, so 2 times 3.14 times 9, then you'll get 56.5. And then circumference, so 2 pi r once again, so 2 times 11, 22 times 3.14, then you get 69.1 centimeter. And now this one is a little bit different, so let's see, 31. Okay, so 31. So let's take a look at that. And let's see what the problem is. So if the circumference of the circle is 72, so what's the length of arc AB? Okay, so this one is kind of like proportionality. So circumference, the measure of the entire circle here, so the length, arc length, it's the total arc length is 72. But the things that we just need to figure out are AB. So since we do know that the proportion, so once you go around the circle, it's 360. So the circumference of the circle is 72. So the way to find out the RAB, so basically just 360, that's the denominator. And then you put 60 right here, because that's the measure of the central angle, representing the arc for this one. And then you multiply by 72. So you get RAB, the measure of arc length. So the way to do it, 72 times 60 over 360, reduce. 0, 0 got canceled, degree sign got canceled. So 6 over 36, that's 1/6. So 72 over 6, then that would be considered what, 12? So the measure of that arc length here, so that's 12. It's not degree for the circumference, is what, cm, I think. Because that's one dimensional. Okay, let's go back. There's no unit, so just put in a number, so it's 12. Okay, so now let's see what else that we have for the rest of this. So 31 is quite similar. So 40 over 360 times 72. So we'll get 8. And then circumference for this circle is 90. So 90 times 60 over 360. So 90 times 1/6. Or 90 divided by 6, 15. And what's the circumference of the circle shown below? So given that RAB, the minor arc, it's 4. So the arc length here is 4. So the way to do it, so this one is just like going backward. So think about this way. So the way that we did it, that was multiplication. But now this time, guess what? We divide it. So 4 divided by 30 over 360. Because 4, that's just the partial arc length of the whole circle here. So multiply by the reciprocals, that's what you did in 3rd grade. Reduce, reduce. So 4 times 12, 48. So the measure of the entire circumference here, so it's 48. Okay, so now let's see what else that we have. So again, this one, so simply just divide it. So that means we multiply the reciprocals of the fractions. So it turns out to be the proper fractions. You need proper fractions for the proportion. Okay, so now 33. So the way to find out the area of a circle is pi r squared. So in order to find out the area, pi times r squared. So that's the way to figure out the area of a circle. So what's the area of a circle shown? So pi r squared, so 18 times 18 times pi. You can always do it on a calculator, so 18 times 18 times 3.14. So we get 1017.9 square centimeters. It's not exact, because pi is an irrational number. So here's another one, pi r squared, you'll get 201.1 with radius equals what? 8 centimeters. So that's another one here. So what's the circumference of a circular swimming pool with a radius of 8 feet? So this one, finding circumference again, radius is 8. So 2 pi r, so 2 times 3.14 times 8. So we get 50.3 feet, one-dimensional. This one too, so radius, so 2 pi r, so 2 times 3 times pi, so 2 times 3 is 6, 6 times 3.14, 18.8. Again, it's approximately. So it's all about circumference. Man, there's so many circumference problem here. What about if that's given with the diameter? So it's pi times d. This diameter is twice as much as the radius. So 3.14 times 20, so you get 60.8 feet. So pi times d, so 3.14 times 10, 31.4 centimeter. Similar, so 37. What's the area of a circular minor with a radius of 10 centimeter? Okay, so this one, just find the area of the circle, so pi r squared. Pi r squared again. And it's always the same kind of problem. It's like a repetition here. So now here's another one, 38. So which is best described as part of the interior of a circle bounded by the arc and two radii that share the arc's endpoint. So this one's called the sector. So region inside the circle bounded by a central angle and its intercept the arc. So area of a sector, so we'll talk about that in a minute. So like 39 here, so this bounded shaded area, so this one is called the area of a sector. As you can see, that is being bounded with two radii, the center and the arc length. Okay, so now the way to find out the area of the sectors. So the formula for this one, so let me just highlight this problem first. Again, copy and paste. Copy and paste this one. So let me see what we got so far. Whoops, copy the link. Give me 1 sec here. Okay, let's go to the new slide. And also I do need the figure. Can you close that door for me, please? It's very noisy.
Okay, Andrew's just loud.
It's very noisy. That's very terrible. Okay, so now here's the circle with the area of a sector, the shaded area, so that's the one. So the way to find the area for this, so it would be pi r squared, so find the area of the entire circle, and then multiply by m over 360. Now let me explain what m is. M is the measure of the central angle. Okay, so m is the measure of the central angle. One thing that we notice, the measure of the central angle is the same as the corresponding arc. So this one will be 40 over 360. So basically just like a proportionality. So once you find out partial area, so the way to do it, just multiply by the representing fractions. So pi times the radius, 8 squared, so 8 times 8, 64 times pi. 40 over 360, this one can be reduced down to 1 over 9, because 40 times 9, then that'll be 360. So, and then the rest of this, you can do that on the calculator. Just round it up to 1 decimal place, I think. So let's see. Yeah, 1 decimal place. So eventually it's 22.3 square centimeter, because that's the area, 2-dimensional. So here's another one. So pi r squared, so pi times 10 squared times 45 over 360. So eventually you'll get 39.3. Okay, so this one too. So pi times 14 squared times 20 over 360. So just put in everything to the calculator, evaluate, and then you'll get 34.2 square centimeters. And question number 40. So which of the following statement is true regarding the relationship between the circle and the triangle? There is only one unique circle that can be circumscribed about a triangle. That's correct. So anytime that you see the polygon, so the circle is always going outside the polygon. It's always circumscribed. So it's always like, getting the point of intersections on a circle with those vertices of the polygon. And there's only one unique triangle that can be inscribed in a given circle. And there's only one unique circle that can be inscribed in a given triangle. It's all pretty much the same stuff here. And which of the following is the characteristic of the incenter of a triangle? The center of the circle that can be inscribed in a given triangle. If that's incenter, so that's just the other way around. So that means the circle, it's inside a polygon. It shows that the equidistance from all three sides of a triangle. And which of the following is the characteristic of the incenter of a triangle? So it's intersections of all three angles, bisectors of a triangle. Okay, so if you see that the incenter, so that's the point where all the three angle bisector intersect. And then which of the following is the characteristic of the circumcenter of a triangle? So that's just the center of the circle that can be circumscribed about the triangle. It's showing that the equidistance from all vertices in the triangles. So if that's a circumcenter, so that means it's always being formed with three perpendicular bisectors of a triangle. So in the diagram below, so circle P is circumscribed about quadrilateral ABCD. What's the value of x? So anytime that you see like an incenter, no, this one is actually not the incenter, it's just the center of a circle. So we do know that the circle, it's circumscribing the polygon. So anytime they see the situation like this, so the opposite angles, they always consider supplementary angle. So the way to solve for x, so you can just subtract 120 from 180. So 180 minus 120, so you get 60. So this one, here's another one. So 180 minus 85, then you'll get 95 degrees. So 180 minus 130, then you'll get 50. And which of the statement is true about the polygon below? It's possible to circumscribe a circle about the rectangle because its opposite angles are supplementary. Okay, so it's all about the rectangle, not the parallelogram. So polygon B, only because that rectangles are the only quadrilateral that a circle can circumscribe. Not the parallelogram, but the special parallelogram, which is a rectangle. Okay, so I think that's it. Yep. So it's a long unit, so make sure that you guys take some time, watch the video, and then try to go through the pre-tests and also the section quizzes. Alright, so you guys take care. I'll see you next time.